How are you, my friends? This video is presenting 6 old exams questions related to domain and range from the graph. So this is related to lecture 29 of the algebra course. Let's start with question number 1. Given the graph of a function f here, we can see that we need to find the domain and the range f of minus 8, x-intercept, y-intercept, f of 0 also. So let's see. We have mentioned in the lecture 29 that pressing method is a good way to find the domain. So we can press all the graph on the x, whatever it covers here, we can get the domain. And then we take the same graph, we press it on the y, whatever it covers, it will be the range. So let's see now the domain. We start from here in the open minus 8 until 12 closed. It will cover all these numbers, that interval from minus 8 open to 12 closed. Now in the range, we go here, it closed, you see this is a closed, minus 4 until 7 also closed. Maybe you will say, why this is open, but we write here closed at 7? Because we have other points, like minus 7, 7, minus 6, 7, minus 5, 7. So there's 7 already in the y values of this function. F of minus 8, where is minus 8? See minus 8 open here, so undefined. There is no value for y if x is minus 8. Let me say that again. If I say here f of minus 8 is undefined, that means there is no value for y if x is minus 8. X-intercept here, this is the point, 3, 0. Y-intercept, 0, 3. F of 0, we take 0 in the x here, and then I go to the graph, it is 3 also. So this is the same as y-intercept. Okay, let's say maybe if I say what is f of 7, look here, 7, we go down until we reach minus 4. So f of 7 will be minus 4. All right, now, question 2, another graph, nice graph. We have A, B, C, D, E, and F. Let's find the domain and the range. What do you think the domain will be? You can write, I think, good idea here, write the answers of all these questions, parts in question 2, and then you can compare it. Domain will be all the real numbers. We can see that this will go to infinity down, so it will be all real numbers. The range now, only the y values if you press it on the y. So it will start from minus infinity until the highest point here is 6 closed. The graph is increasing. We have an increasing here, and we have another increasing there. Decreasing also, 2 intervals. Let's see the answer. Domain, as I said, all the real numbers from minus infinity to plus infinity. Range from minus infinity until 6 closed. Increasing, see, increasing or decreasing, we take the values on the x. We're increasing, where the graph is rising from left to right until minus 1. See, we take only the x values. So from minus infinity until minus 1, union. Now there is a 0 and there is a 2 here. The graph is increasing until 2. We don't take the value 6. No, that's the maximum. Now decreasing from minus 1 to 0, see my decreasing, another decreasing here. It will go to infinity from 2, not to 3. It will go down to infinity. Number of x-intercept, we have 1, we have 1, we have 1, so 3. Why I did not say find x-intercept? Because we cannot find the value from the graph if it is not clear. See, this one may be 2.7, 2.8, 2.9. So I said find the number of x-intercept, there are 3. F of 2, so I go to the function here, 2 in the x. I go up, it will be 6 there, see? F of 2 is 6. F of minus 1, it will be 1 there. Minus 1 go up to the graph. So 6 plus 1 is 7. The y-intercept only 0, 0. Another graph, another questions, 1, 2, 3, 4, 5, where the graph is above the x, below the x, etc. So above the x, where is the graph above the x? This one above the x until here. Now let's see the first part, above the x-axis. we can see above the x, starting from on the x-axis from minus 8 here, minus 8, it will go until 3, above the x, open interval. This is above the x, below the x. See, from 3 below the x until 12. But this point is closed, it's included. So we say below the x, we say open 3 until 12 closed. Remember, minus 8 here, it was open already. Now decreasing, we see decreasing, all this decreasing function, it goes down like this, but from where? From minus 4 until on the x until the 7. So minus 4 to 7, the interval is decreasing. Constant, let's see where the graph is constant. We have two pieces where the graph is constant. From minus 8 until minus 4, see that one here? And then union from this 7, constant from 7 until the 12. So that's two intervals where the graph is constant. No increasing. Graph is not increasing on any interval. Now let's graph this function, f of x, x minus absolute value of x, and find domain range and increasing. Now you have two ways to do this. I take two cases when I see absolute value about the x. So I say if x is greater than 0, then we know absolute value of x is x. So I can replace x minus x is equal to 0, y is equal to 0, which is the x-axis. But remember, graph it with positive x. Why? Because the condition I started with. So the positive x will be all this x-axis. Now, if x is negative, the absolute value will be minus x. That's a condition. That's the definition of the absolute value, actually. So x minus minus x will be 2x. 2x, I take 2 points in the negative. Remember, x negative. So I take minus 1, it will be minus 2. And then I take minus 2, it will be minus 4. So I draw this line. So this black here is the graph. See, it's very nice. This is x minus absolute value of x. Let's find the domain or real numbers. Press it on the x. If you press it on the y, see this one becomes on the y negative and then also 0. So minus infinity until 0 closed. Where the graph is increasing like this. See, increasing from minus infinity until the 0 on the x-axis. Or the second method I told you, there are two ways to do it. Either you take two cases, absolute value of x, one time positive, one time negative, or just take some points and make sure you are accurate in the points, then you can graph it. Number five is similar to our example 7 in the algebra course, lecture 29. This is a parabola, 6 minus x squared, but there is a condition here, x between closed minus 2 and 4 open. The domain, I called it A to B, and the range C to D. Find this value. So clearly we have to graph it first, and there is a condition. From the condition, guys, I told you in the lecture, you can take this trick. From the condition, directly you can find the domain. See, this is a little trick. Put here minus 2, close. You see that close, open 4. So this is A and B. The domain is given. Now the range, you have to check the graph. Look at the graph here. Oh boy. Take minus 2, take minus 1, 0. You can take 4 also. See, 6 minus 4 squared, 16. So that's minus 10. But remember open, because x cannot be 4. See, I take 4, but I make the point open here to know what is the range, what is the y value. So now the range, I told you the domain minus 2 to 4, the range will be open from minus 10 until the highest is 6. See? Now multiply AB plus CD minus 8 minus 60. So minus 68. Another nice function with absolute value, f of x, x over absolute value of x, you can also do two ways. You can either take some points, but remember x cannot be 0, or you take two conditions, x one time positive, x one time negative. This is what I prefer. So that's the function. Remember here condition, x cannot be 0. So if I say if x is greater than 0, I know the absolute value is x. So I put x over x is 1, horizontal line. See, this is the line. X positive, remember, I cannot extend it here. If x is negative, the absolute value is minus x. This is definition, guys. So f of x will be x over minus x, which is minus 1. Another horizontal line. Remember, x cannot be 0. So now what is the domain? Domain, all real numbers except 0 if you press it on the x. Press this on the x, press this on the x. All real numbers except 0. Or the range will be two numbers. Press it on the y, it will be only 1 or only minus 1. Two values in the range. So the range only minus 1 and 1. Not minus 1 to 1, minus 1 and 1. Two numbers only. And domain, all real numbers except 0. We can write domain if you like this. Minus infinity to 0 open, union, 0 to infinity. Please write it down. You can write that if you like. Again, domain, minus infinity to 0 open, union, 0 open to infinity. That's one answer. Same answer as R except 0. Or in English, all real numbers except 0. Now, these are the answers for these 6 questions. Again, for other examples, if you like to see other examples, please, you can visit the Algebra course lecture 29. We have many examples there. Thank you for watching. If you like the video, you can subscribe and share it, please, with your friends. I wish I can see you in another video with another topic. Thank you very much.